Hello everyone, welcome to Genius Blossom. In this part of the lesson, we will understand how water can quietly turn into vapor even without boiling, a process known as evaporation. And you might think that to change water into liquid, we need to boil it or heat it up, but that is not always the case. Think about when you leave a glass of water uncovered, what happens? Over time, it slowly turns into vapor even without boiling, or when wet clothes dry up in the sun. Yes, that is evaporation happening right before your eyes. So how does this magic happens? Well, the particles in the liquid, they are always in motion or they are always moving around. And at any temperature, some particles on the surface, not the point, some particles on the surface, they move fast enough to escape into the air and turning into vapor. And this process is called evaporation. And this evaporation, it happens at the temperature below its boiling point. So evaporation is the phenomenon in which the particles from the surface gain enough energy to overcome the forces of attraction present in the liquid and change into the vapor state. Like melting, evaporation is also a surface phenomenon. While boiling, it is a bulk phenomenon because the process of boiling, it happens throughout the liquid. So what exactly is evaporation? It is when the liquid water turns into vapor and goes up into the air even without boiling. It happens all around us, like when puddles dry up after rain. So what is evaporation? Evaporation is the process of change of liquid into vapor at any temperature below its boiling point. That is, the change of liquid into vapor at any temperature below its boiling point is called evaporation. Next, the factors affecting evaporation. Let us do some simple activities to understand the factors affecting evaporation. Take 5 ml of water in a test tube and place it near a window or under a fan. Take 5 ml of water in an open dish and keep it near a window or under a fan as well. Take 5 ml of water in an open dish and place it inside a cupboard or on a shelf in your classroom. Record the room temperature and the time it taken for the water to evaporate in each case. Repeat this activity in a rainy day and compare your results. You must have seen that water evaporates faster in some cases than in others. That is because certain conditions can speed it up. For example, water in the open dish near window, it evaporated faster than water in the test tube. Why? Because the open dish, it has a larger surface area. Just like when we spread wet clothes out while drying, and they dry faster because of the increased surface area. So the rate of evaporation increases with an increase in surface area. Now think about when we place the dish under a fan or on a windy day. What happens? The water evaporates more quickly. That is due to the wind carrying away the water vapor. It is the same reason clothes dry faster on a windy day and the wind helps the water evaporates faster. So the second point or second factor affecting evaporation is wind. Also when it is warm or sunny, the higher temperature, it gives more energy to water particles, making them escape quickly. And when we put the dish inside a cupboard or shelf where it is still and possibly humid, the evaporation slows down. So the factors affecting evaporation are increase in surface area, strong wind, higher temperature and low humidity. How does evaporation causes cooling or evaporation causes cooling? Why? When a liquid evaporates, it takes energy from its surroundings and this energy, it is used to change the state from liquid to gas. As the surroundings lose energy, becomes cooler and that is why evaporation causes cooling. When you put acetone or nail polish remover on your palm, you feel cool. Why? When you put acetone or nail polish remover on your palm, the liquid, it begins to evaporate and as it evaporates, it absorbs energy from your palm to change into vapor. This absorption of energy causes your palm to feel cool. Similarly, after a hot sunny day, people sprinkle water on the roof or open place and the large latent heat of vaporization of water helps to cool the hot surface. Using earthen pots to keep water cool. It is also an example to show evaporation causes cooling. Have you ever wondered cotton clothes are so comfortable to wear in summer? Cotton clothes are great because they absorb sweat on our body and allow it to evaporate easily. Where the sweat on your skin or body evaporates quickly, helping your body stay cool and comfortable. Have you ever noticed water droplets on the outside of the glass filled with the ice cold water? When you pour ice cold water into a glass, the air around the glass contains water vapor. When this warm, moist air comes into contact with the cool surface of the glass, the water vapor, it cools down and loses energy. As a result, it changes from gas into liquid and we see it as water droplets. So in conclusion, evaporation, it is a surface phenomenon that occurs faster with a higher temperature, wind speed, surface area and lower humidity. It is an essential process that helps in cooling and plays a vital role in our daily life and nature. Why does a desert cooler cool better on a hot dry day? Because the dry air helps water evaporates faster, which absorbs heat from the surroundings and cools the air. How does the water kept in an earthen pot become cool during summer? The pot has tiny pores through which water slowly evaporates, and this evaporation cools the water. Why does our palm feel cold when we put some acetone, petrol, or perfume on it? When we put some acetone, petrol, or perfume on our palm, it evaporates quickly. During evaporation, it takes heat from our palm, making it feel cold. Why are we able to sip hot tea or milk faster from a saucer rather than a cup? We are able to sip hot tea or milk faster from a saucer rather than a cup because a saucer has larger surface area which increases the rate of evaporation and cools the liquid more quickly. What type of clothes should we wear in summer? We should wear cotton clothes in summer because cotton is a good absorber of sweat and allows to evaporate quickly, which helps cool our body through evaporation. Now let us quickly go over the key points we have learned in this lesson to make sure everything stays fresh in your mind. Matter is made up of small particles. Three states of matter are solid, liquid and gas. The forces of attraction between particles are maximum in solids, intermediate in liquids and minimum in gases. About the spaces and kinetic energy of the particles, it is minimum in the case of solids, intermediate in liquids and maximum in gases. About the arrangement of particles, in solids it is most ordered. In liquids, the particles can slip and slide over each other. In gases, there is no order, particles just move about randomly. The states of matter are interconvertible. The state of matter can be changed by changing temperature and pressure. Sublimation is the change of solid state directly to gaseous state without going through liquid state. While deposition it is the change of gaseous state directly to solid state without going through liquid state. Boiling is a bulk phenomenon while evaporation is a surface phenomenon. Factors affecting evaporation are an increase in surface area, the wind speed, higher temperature and lower humidity. Latent heat of fusion is the amount of heat energy required to change 1 kilogram of solid into liquid at its melting point. Latent heat of vaporization. It is the heat energy required to change 1 kilogram of a liquid to gas at the atmospheric pressure at its boiling point. Some measurable quantities and their units to remember. Naphthalene balls disappear with time without leaving any solid. Naphthalene balls disappear with time without leaving any solid because they undergo sublimation. That is, they directly change from solid to gas without becoming liquid. This is why they slowly vanish when exposed to air. We can get the smell of perfume sitting several meters away. We can smell the perfume from a distance because its particles diffuse into the air and spread in all directions. This happens due to the diffusion where particles move from a region of higher concentration to lower concentration. Water at room temperature is a liquid. Water at room temperature is a liquid because it has a fixed volume but no fixed shape, takes the shape of its container, it can flow, it is not rigid. It shows all the characteristics of liquid, so it is classified as a liquid. An iron almirah is a solid at room temperature. An iron almirah is a solid at room temperature because it has definite shape and volume, is rigid, and its particles are closely packed with very strong forces of attraction. These are all properties of solid, so it is a solid at room temperature. Arrange the following substances in increasing order of forces of attraction between the particles: water, sugar, oxygen. Increasing order of force of attraction between particles: oxygen, water, sugar. Oxygen is a gas, very weak force of attraction. Water is a liquid, moderate force of attraction. Sugar is a solid and very strong force of attraction. Why is ice at 273 Kelvin more effective in cooling than water at the same temperature? Because the ice needs to absorb extra heat energy, that is the latent heat of fusion, from its surroundings to melt into water. This absorption causes a cooling effect around it. So, ice at 273 Kelvin is more effective in cooling than water at the same temperature. What produces more severe burns, boiling water or steam? Steam produces more severe burns than boiling water because steam contains the latent heat of vaporization in addition to the heat it has from being at 100 degrees Celsius. When steam touches the skin, it condenses into water and releases this extra hidden heat, transferring more energy to the skin and causing more serious burns than boiling water. Now it is time for your homework and I have two questions for you. First one, convert the following temperatures into Celsius scale. Remember to convert Kelvin to Celsius. Celsius is equal to Kelvin minus 273. And our second question is convert the following temperature into Kelvin scale. And to convert Celsius to Kelvin, Kelvin is equal to Celsius plus 273. With this, we have completed the entire first chapter and I hope you understood all the concepts well. Thank you for watching and I will see you in the next video with a new chapter. Keep learning and stay curious.